Alright, we got a couple.
That was not my fault, actually. You tried to catch it.
Just bring it into the water.
I'll be right back.
That's really fun.
Look at how those little balls roll.
What?
Watch this, guys.
Yeah.
Look.
What?
Woo!
Look how those slide across.
Oh.
Are they really frictionless?
No.
No, think of an air hockey table.
Yeah, that's how they make air hockey tables. They use dry ice.
Yeah, that's right. No, it's not right. Again, the pressure of the stuff evaporating so quickly. It's heating up so quickly, it's creating pressure, it's creating a cushion of air.
We
underneath
need,
it as it slides across.
We need a thermometer, dude.
Probably right there.
Where?
You're looking right at it, right by the
Oh.
punch. I
There
don't know how
goes.
low that one goes though.
Yeah, I know. Come here, Dad. First off, stick your hands in here. Keep in mind, this is about, I think this is 3 or,
Alright, we just said we were gonna do it up front.
3 or 4 days. I know, but just
Whoa, that's cool. That feels really good.
pretty cold. Let's see.
Low.
Low. I don't know how low that thing goes. So.
Oh, that's awesome. How cold is this?
Oh, cool. It's pretty low. Hold on. Let's get a real thermometer here.
It's awesome.
Yeah. I don't like that one that came off. Where do you have more of those, Dave?
There's these two. Yeah. Take one of those. Take this one.
Why?
Here you go.
Why buy this?
We didn't buy it. AJ's dad works for what?
Ice cream.
No, yeah. What is glue? Glue is what type of thing? It's a adhesive. Yeah, it's an adhesive. AJ's dad works for a company that works for adhesives, and so adhesives, when they're really cold, they don't adhere, and so when they deliver them with dry ice. How cold do you think it's gonna get? Do you think it's colder than 0?
Yes,
Why?
because it's going straight from the solid to gas.
So?
So there has to be a really big difference.
Wait, what's the one straight from solid to gas?
The dry ice.
When does it? Wait, what?
Solid to a gas.
When? It's all solid right now.
Yeah, in room temperature, when it's out, you see it's steam.
So?
It's going from solid to
Yeah.
gas. Mm-hmm.
So? What are we at right now?
It's really low.
What are we at right now?
No.
-12, -15. Pretty cool.
It's still going down. We're not going to see it.
We're going to see it so low, down by -20. It's probably not going to be able to read it. You're probably just not going to see it.
as slow as it goes.
Yeah, a little bubble of mercury at the bottom. How do you know that it is? Feel that.
Oh.
It's crazy. How do you know that it is, that it has to be below 0? Think about that. Because of this. CO2.
You need lower temperature to increase the
Yeah, you need CO2 at room temperature. It is
gas.
gas. We know that. How cold do you have to get it to get? Do you guys know of liquid CO2? You ever heard of liquid CO2?
I have to go see.
Liquid CO2, you would only see it in something that looked like this.
Alright, here we go. This will work better.
You would only see liquid CO2 in something like this. You want to see liquid CO2? I'll show you liquid CO2.
Okay.
Mr. Gottschalk, what's your liquid CO2? Here's Mr. Gottschalk's liquid CO2.
That's not liquid CO2.
What is it?
It's nitrogen.
Nitrogen. Dang you. But either way, you can feel the fact that it's liquid. The reason that by this.
This is next chapter stuff. Yeah.
Thanks.
Shake.
Ah.
Then you can feel that it's liquid. You spray it out and it's a solid. But is this cooler? No, it's not cooler because it's pressurized. That's the PV equals nRT. You can change state of matter based upon pressure, but as soon as we release pressure, it comes back to gas. Now, we know that temperature has to do with phase change. And so by definition, that had to be lower than 0 because we knew that the melting point of CO2 is lower than the melting point of H2O, and hence it had to be lower than 20 degrees. To see here, give me a couple of chunks of that.
This is working pretty well now. It's as low as it goes.
That's awesome.
30, it's about negative 50 right now.
Whoa!
The process of
Well, what should it be? I mean, it's dry ice. Look at the
the
boiling
process
point
of
there. Should be at least
sublimation is pretty
80.
cool.
Well, now it's already going back
Look at
up.
this.
You can see how low the mercury is there.
That's the process of sublimation.
That's so cool.
Hey,
Come look at that. And you know what's really cool about this? Let's talk about density. What can you tell me about actual... Don't do that.
What the heck?
it's cold if you hold it in your hand too long.
That's why I have gloves, dude.
Yeah.
Alright, so what can you tell me about the density of this stuff? You hear
It's
bubbling?
really dense.
Yeah. But
That is so cool.
you can pour the steam. Is
Oh!
it steam? No, it's not steam.
Hold on. Move the. Move
It's
this.
so weird.
Okay, so we're not doing...
Well, it's
The water feels warm.
You put liquid
4 or 5.
H2O in there too, right?
A little bit of H2O. Yeah. A little bit of H2O.
That is so weird.
Now what do you hear boiling? Not the water, it's the CO2, right?
Yeah.
You can see.
Yeah, if you look through here, you can kind of see it.
Yeah, that's pretty crazy. Is you can pour out the.
And the reason you can pour it is because it's so much more dense than the regular air.
Why?
We talk about, why is it
Why?
more dense?
Because the amount of particles are so close together.
Why?
Because they're not moving.
Because they have, why?
Think about the process.
Move
What
over
process?
Right here.
What process? Right now. Come on, man. Yes, sublimation. So it's going from where the particles are like jam-packed together like this to the part where they're here. Well, somewhere in the middle, they're going to be a gas, but they're still going to be
Together.
really close together.
Well,
Dense.
how about just
gas.
the fact that because they're so cold, it's cooling the atmosphere to a lower temperature and making that more dense? You know, I mean, you're putting this stuff in the atmosphere, you're taking heat out of the atmosphere.
That's cool, the way that it happened. It doesn't happen in clear bubbles like that.
It doesn't. Oh yeah.
No, see, they're white.
Yeah. So weird.
You can feel the temperature of the if you blow like that, the temperature of the fog is really cool too.
Now, why does it all disappear once it
You
gets
don't
out
feel
of
it
the
on your
bucket?
hand.
Because
Put your face on it. You'll feel it though.
Stick your face in, Stu.
Why does it all disappear when it hits
it
the
looks like
atmosphere?
we're gonna get high off of this.
Oh, stop.
What?
It's
Blow.
colder.
Blow when you stick your face in there.
Oh, like
Not?
that. Yeah.
Don't inhale.
Feel what's weird is the water's not that cold. Now it's getting pretty cold,
Yeah.
but
It is.
it wasn't that cold to begin with.
All right, for the 20th time, why does it disappear when it gets out into the regular atmosphere?
Cause. Oh, that's cool. Oh, that's really cool. Cause it wants to.
How long will it
Cause
take?
okay. Cause you're saying how
does it
the other
dissipate?
day,
Give me that water.
like when you breathe out in cold air, then like it goes through
Yeah,
three
what
phases
happens?
or whatever.
What happens? Which phases?
The evaporation, condensing, and evaporation again.
Right, okay. So is that what's happening here?
No.
We're seeing...
I don't want to hear you evaporation. Vaporization this word.
Vaporization? No, okay. Alright. Well, the fog you are seeing is not CO2. You are seeing a cloud made of H2O. Okay? Why? This is water right here that you're seeing.
Oh. Because it's.
This is water droplets. A lot of it is. Why?
Does the water become less?
You're cooling down air that has water absorbed in it, right? There's water in the air all around us, okay? And you're cooling it down so much that that water can't stay in the air as a gaseous form, so it condenses into a liquid, into a cloud. And that's what you're seeing. Now, once it mixes with the rest of the atmosphere, there's enough capacity in the bigger part of the atmosphere to reabsorb it all as water vapor.
I just want to take this home with me to look at it. Yay!
How do they use it for smoke machines? Like, how do they use it?
Watch. This is how. You put water on it and let it sit.
You know how it was bubbling over here before we got in? That's how.
And that's what it creates this. If you just have a plethora of that and you sift water through it, because what is water doing when water passes by in here? It is what process? Condensing. Okay? Water is
So
condensing.
how do they get so much of it to pour out without it turning?
They just
being absorbed back in
they heat it up fast. That's all. They heat it up fast. The faster it heats up, the more.
That'll kind of come with next chapter too.
Yeah.
When we talk about processes.
It's but I mean, yeah, there's some water vapor in there, but a lot of that is the CO2 that's being dissolved, and there's the water, the air can't hold on that either.
Right.
We're contributing to global warming right now.
Are we?
CO2. We're putting CO2 in the atmosphere.
Yeah.
But
It's cold.
It is cool. It's. I can't believe it still hasn't all completely
Oh my god!
sublimated
That's
yet.
so cool! It just froze!
yeah, that's
Is that the mercury?
the mercury. Yeah.
It finally froze!
I don't know. It actually
Did it
froze.
froze?
No, it didn't freeze. You're just seeing it inside the.
This thing.
Here, bring a couple
It's
pieces.
Celsius, yeah. So this goes
That
down to
is
-20.
cool.
And this is about right. It should be around -70, right? That's what the freezing point is. It should be below. It should be below 78.5. And this thermometer doesn't go that low. That's what it is. Just take it.
I know. You can actually see
with me.
the same process here. It's interesting to see why, when you move it, it creates more. You know, when you move it, when you
The
hit it,
camera's.
it smokes a little bit more. Why is it white? Actually, don't know the answer to that.
But it's clear over
No, I'm not asking
The steam is white.
the gas is not white.
It's only white
The
because
gas is always clear.
Oh.
Dense.
it's only white. No, it's only
And
white because
what
it's
is-
reflected. You're seeing the light reflect off little droplets.
Okay, so what is white then?
He's
Same
saying
reason
white.
clouds are white. Clouds are white.
Oh, okay.
White is a combination of all the colors.
Whoops.
Reflecting off all the vapor.
That is so cool. Can I order some glue from
You
your
can order this. You can order this from Mike.
You can buy this at Jewel.
Yeah,
You
you
can
can.
buy it.
Oh my
Yeah,
gosh!
it's kind of expensive.
Yeah, well, I am.
Yes!
Yeah.
I win.
It's like, I want to say it's about $2 a pound.
Oh, cool. That's cool.
You need to warm for that to work.
Yeah. The thing is, it's only really cool when you get warm stuff, because that's when it reacts really fast.
Oh, no.
Yeah.
Where's my laser?
I always mess up everything anyway. Oh, there it goes. Your table's free. Yeah, that's not gonna do anything.
So we're just videoing people playing with it, I guess, for Taylor.
Pretty much.
What about that cap? Why'd you stick it in that film capsule?
Well, eventually it's going to warm up and pop. The cover will pop off.
If you
If
held
you
it,
put a little water in it, it'd pop.
oh, it would pop quick.
Is it cold?
Can we have
It's not that cool.
paper towels?
Mm-hmm.
We need some.
Mm.
anything lethal if I spray this on the ice?
No, don't.
Okay.
It shouldn't matter, but yeah, we don't need to.
Okay. Just wanted to see.
He has a bunch of gold oil cans around his office, so he blew a couple up.
Uh-huh.
And it was cool to see, like, when we put it, we made a water bottle, like, completely disappear. But you could see, like, how they built, like, like, how a machine made it, because it had the same weak points, like, 2 holes in this opposite ends. Pretty cool.
That was so cool. Just like watching it spin. Okay,
And
yeah.
that's a
we
good,
need-
that's
we
a
need
good
to
study
take
of
the
turbulence too. Turbulence and drag and stuff like that. You can see how the stuff blows off. How currents change when it hits something in the middle.
That just looks so neat.
Yeah.
You can tell the water.
It can.
Really?
It can. Yeah. It can.
Oh yeah,
because
that's what it was leaving.
It's 80 degrees
Yeah.
cooler than the water.
That is so cool.
You trying to figure out the lowest temperature, Mick?
Yeah.
I don't know how cool that thing goes.
I go down to negative 34.
Okay. It probably goes down to negative 35.
Or 40.
I'm just gonna play with this. I don't remember
You see
my
laser
eyes.
in the light.
Now that I actually get some
Go
info.
down to negative 40.
Maybe 40. Mr. Gutsch, where did you go?
He said, oh, negative 85, you would say?
No. Go down to
Wait, I want to see this. Woo!
That's the box, right?
40.
Wow.
What are you doing?
Oh my god.
Do you want me to blow it?
No.
Oh my god. My hand, like, circus in my hand. Oh my
It's funny, this table's not level.
Does it hurt when you do it like that or no?
The table's not level.
This water is fairly
Oh,
hot.
No, because it's going that way now.
Vibrating, yeah.
Why do you also not want to breathe in just the vapor like the fog?
I don't know.
You will suffocate
Oh, okay.
because there's too much CO2, not enough oxygen in there.
Oh. Woo! That's awesome! Woo!
That's very cool.
That's so cool.
That's so sweet.
Oh my gosh.
Now where'd my laser
That
go?
is so
Find the
cool.
laser through there, Mick. You should be able to see the beam.
It would say low.
Where's my green one?
You just don't see the beam.
Well, plus, we need to do some great stuff with light diffraction here too.
Yeah, take it
Run,
everywhere.
Mr. E, run.
You're taking my experiment away, dude.
Whoa, that looks so cool.
So you can see the laser shine through a little bit.
Yeah, that's really cool.
Yeah, down there.
Oh, that's how they do those little
Right.
Yeah, that's how you do the laser light show.
Yeah.
That's why they almost have fireworks before it, so that you can get enough stuff in the atmosphere for it to bounce off.
It's just like you're disrupting my class.
Put it back up here. Yeah.
It's so cool. What if this thing freezes?
This is also a good opportunity to show
Oh,
you
wow, it's still warm.
More.
the fact that light is a wave
Right.
and has an interference pattern.
Because,
My hands are cold. Did you
well, this is funny too, yeah. Because this is actually warm now. Feel that.
Yeah.
Yeah.
Oh,
It's
whoa.
weird.
That is so
So
weird.
this here is pure CO2.
Right.
It's not warm because there's.
Would it make our hands nice and soft? Is it so moisturized?
I don't know. Yeah, because it's not reflective. Look over here. There's no wave. See
Whoa.
that?
Yeah.
You know why it does that? Because light is a wave and a particle. And that's what you're seeing is an interference pattern.
It's like milk.
It's getting little. Yeah, it's
What?
definitely getting little.
It's like milk.
Ah! Sorry.
Actually, it's melting like
Trying to take a breath of that? What happened?
What?
Were you taking a breath when I did that?
Yeah.
What happened? What did it feel like?
That was weird.
Just blows from.
That looks so cool.
Alright, let's replenish it. What's the temperature of that water like, man?
It's still, that's decent.
It's cooling down, yeah. Oh, wait, yeah, it's cool water now. Look at some
The
more
fog
hot.
is still warm though.
But it's still hot compared.
Yeah.
But you notice this one was not like that huge, like,
Yeah.
because that was hot water before.
Oh, that was so cool.
And this now feels cold again.
Yeah.
And this one is getting cooler, yeah.
Yeah, this one's getting cooler.
I just want to play with this all day. This is the coolest
This
thing.
is. There's that goes. It doesn't really.
Yeah, I was just trying to blow off the,
See, it's not as cool unless it's very much separated from.
Dump it all in there, yeah.
Woo!
The water's.
Yeah, the water's coming over.
Oh.
But what is this process again?
What?
Process?
Yes, sublimation. I told you, it's semi-unusual. It's not something that you're going to see on a regular basis. But the issue is that this is sublimation a ton. This is happening a whole bunch at once.
It just stays in your hand. It's so cool. Ooh. It just looks like clear or something. It's so weird.
Did you ever get any balloons?
What?
Mr. Ernst, did you ever get balloons?
No.
That's too bad.
Here, some water.
Yeah,
Yeah, it's cold.
I cool my coffee down with this stuff.
This is the coolest thing.
Here's one right here. Cold, but
Oh yeah, it's really cold.
What if we put it in pots?
In what? In pop?
Right.
Can we put it in pop?
What would happen if we did put it in pop?
Does it not let you
Pop right.
It wants to pop right away.
Yay!
Here, this one's got dry soon. Yeah, drop in the water. Make it pop faster.
What did you put in?
Dry some water.
I don't know if that one. I don't know
I
if
wish
that
it
one's
popped
airtight. That's
off,
the problem.
Yeah, this one's got a little sticky.
If we put a water,
This
like
is
in
gonna
a
have
water
to
bottle,
test
would
it,
that work?
Oh my god. If we put it on this, if we put a bunch of dries in this and water, cranked it down,
That'd be bad.
it would be bad.
Okay.
It would be, because it would build up so much pressure, and when it did go, boom!
You can see the water bottle when you do it expand though. It gets like this big.
Right.
Really?
Yeah.
Yeah.
Just do it.
No,
Can we do
that's
that?
hazardous.
The problem is, sometimes the cap pops off, and if the cap pops off, it'll take out your eye. Like,
See,
it's nuts.
The cool part is, can you find it? Oh, here it is. If you get it upside down, then you can make the top pop, or the bottom pop off.
No, the water.
Close. It won't even let me close it. There. Come on.
Go. It's
All the
close.
water's out. Yeah, it's. I think it's escaping somewhere.
Oh,
You should hear it.
What's wrong?
yeah! That's awesome.
Hey,
No. Okay. Oh.
Okay. So don't let it go. Let it go. No, it's
Yeah, it's leaking out. We need to tape.
No, it'll explode.
it's come out.
Yeah, it'll come out somewhere. It's. Wait.
It'll lift it off.
Guys, we have covers.
I'm curious if it'll pop this guy off.
Oh, I don't know. Yeah, we can try that. There's not enough dry ice. We're gonna grab some dry ice.
This is the coolest class ever.
I was saying like if it just stays here and
Oh, that's possible.
If there's enough.
I don't. There might be enough for in. There's some water.
Oh my gosh.
Put that cover on.
I don't feel it.
It's not tight enough.
Yeah,
You can hear it.
Or you dump it in, AJ.
Yeah. It's kind of
It's
like.
not airtight
AJ, come over here and dump that.
Yeah.
Go ahead, just dump it on.
That's gonna be the same as this.
You can see it.
It's awesome.
Yeah.
They-
Just
Stand on it. There's too much gas coming from, you can see.
Yeah, it's bulging.
Just kidding.
Boom!
That'd be awesome, though.
now, if we do just a little and put the cover on, we might have a stand a chance then.
No, it's too cold, the water's too cold.
Okay.
Yeah, do one
We'll
more.
get some more water, Lee. This is below zero water, guaranteed.
Really?
Yeah.
And it's not frozen.
Where's the big thermometer in this thing?
49, yep. Fahrenheit, which we know is
Yeah.
going down still. Oh, yeah, that's.
I mean, you stick your hand in there, you know it is.
Oh,
Where
that's
is,
freezing.
Are you sure,
something
babe?
that's
I have the
freezing
cup.
very
No.
quickly, or relatively speaking.
Yeah, you gotta give more water than that.
I got some.
Pardon me. What is he doing?
Put that in there though. It should.
Yeah! No, I thought we were gonna put warm water in. That looks kind of cool actually, that's good. Yeah.
So what's the pressure's increasing? It's a
So it's
the
trying
volume's
to
constant.
change
So
the
it's,
volume.
yeah.
That's so
Looks
cool
pretty nice.
though.
Let's see how fast that.
Oh my gosh, I didn't know it would go that fast.
That's pretty cool.
Bulging.
It's not actually coming out of her, is it?
No.
No, it's
Pretty well
expanding right now.
No, the bottom one blow
Let's
up.
hope it's the top.
Yeah.
The bottom one blow up.
That sounds loud in there. Do you know why it sounds so loud? Sound travels more slowly through CO2, so it's more dense. It's a more dense sound, it's like traveling more sound.
The top's not coming out.
What the heck?
No, you know what? The boiling slowed down because this is sealed so well that it's not allowing it anymore to get in the atmosphere or to get in the air in there.
But I want to see. Should I do it?
It's gonna take a bit.
It is still boiling slowly. It's still coming out slowly.
Okay.
But, I mean, give me another cover from back there on the desk. Let's cover this one up now too. It's too loud. Back on the desk there should be a couple of covers, a couple lids. There you go.
What's mystery called?
We have to get some more water, I think.
Ooh, there it is.
Okay.
Seen it well.
I'm waiting for that one to go.
Yeah, me too.
I love that.
That's so awesome.
That's what the film cast was supposed to do. I think this is a little bit better.
What's popping?
This, it's working.
It actually works better when it's slower, huh? That's sweet.
That one doesn't.
Yeah, that one has been on
It's
here.
got a leak.
No, it's
Oh, look
really?
at it.
Yeah, it's bulging.
It's got a leak.
It does not have a. Well, where does it have a leak? It's
It slowed down
You're
boiling.
hearing this
There
one?
goes weather, you're joking.
Yeah, there might not be enough in there.
What are those?
What is that?
Just an old rubbing alcohol container.
That's gonna blow up.
There's no alcohol in it.
Are you gonna twist it?
I don't think so.
Because then it will blow up.
Like,
Right,
if you twist it on, like,
because-
one
Yeah,
way.
just think about putting it outside and blowing it up.
Ooh.
Put it outside, we all stand here.
Leave it in there. What's in there now, I think it's gonna blow up.
Here's
Oh,
ice.
It's gonna, the valve's gonna expand first. I mean.
Yeah, that's turning that
Yeah.
water. That water's turning into ice.
That is so cool.
But yeah, it's still boiling.
Yeah.
Not this way.
That's awesome. That, like, never gets old.
Put it on and then carry it into the thing.
I'm just curious about the.
Okay, that looks weird.
Oh, look how it's eating right through it.
Coffee everywhere.
Alright, so
That's it.
there's way more flying around. I think we're
Yeah, that looks kind of gross.
You never got balloons, huh?
This is like all right.
Ooh, that's cold.
Woo!
These are like ice. And water.
Now, this is cool because we talk about it all the time. You guys know what we're writing here.
Oh, look at that go. Oh, that's so nice.
But this actually physically, visibly shows you as the ice warms up, the CO2 particles do what?
Makes state? No.
Come on.
What's that called?
As the ice warms up, the CO2 particles do what?
It's what's making that cover pop off.
They start moving.
Because move
When the ice is warming up, what's happening? We're transferring internal
and
energy
move
to the CO2.
Yeah.
fast, which causes
Boom.
Okay?
the substance to
That's so lame.
Alright.
what? Rick,
Gus.
you said it.
I didn't say it.
You did. I thought. Expand.
No.
That's so lame.
Yeah, that
And
one.
look at that
The
eyes.
seal's not good.
Yeah.
So what's with the boiling?
Is
that boiling?
No.
Is it boiling? No, Sue? Mick, is it boiling?
So low.
No.
No? Ann, is this boiling?
It sure looks like it.
AJ, is this boiling?
Here, try this rubber band.
Sue, it's not boiling? Hey, Mick, it's not boiling?
No.
Are you, look! Sue,
Well, it was better.
Come and look.
First took it out,
so what? Mr. Gotchuk, is this boiling?
Yes,
What's
it
boiling?
is
The water?
boiling.
No.
The water is not, but is the CO2?
Oh, yeah.
Of course it's boiling, look!
You just say it
It's
is.
hot!
Is it boiling? Yes, it is.
The CO2 is definitely
That is
boiling.
hot CO2. That is very
That is
hot.
very hot CO2. Which is kind of weird to think about because it's like, oh, it's cold.
It's
hot.
relative.
Hot CO2, correct. It is all very relative. The CO2 is definitely boiling.
I really want to put hot water in again. That looks so cool.
What are my tongs like?
Smell like coffee.
Oh, vibrating tongs?
That'd be a big thing.
Talk about iced coffee.
Yeah.
How's that coffee story?
I like ice coffee. I get this stuff around more often. It's slightly carbonated too.
That's true.
This is water. This is regular water. It was from a.
From where?
It was just from the water cooler there. I put some CO2 in.
Oh, really?
Yeah, it's slightly
Tastes carbonated?
It's slightly
Laced with
carbonated.
CO2.
It also tastes acidic because CO2 is an acid. It can be acidic. It makes water
Does it taste
acidic.
really gross or?
It tastes like carbonated water.
Don't take a big gulp, just a little
It
bit.
tastes like seltzer water.
Yeah. But when I first did
Which is
it,
disgusting.
I breathed in a big breath and I got lightheaded because I breathed in like pure CO2.
Passed out.
Yeah.
I know what it
And
is.
the newspapers the next
Just
day.
like hot water.
Physics teacher passed out from CO2.
It's sour.
Yeah, it's sour. It's
weird.
acidic. Yeah.
It's just like that.
That's one thing in the
Stuff
pot.
is settles.
CO2 is dissolved in
That's
the water.
disgusting.
It is
CO2
kind of gross.
dissolves. Well, this is actually good too because CO2 dissolves in the oceans. The oceans is what keeps a lot of CO2 out of the atmosphere. It keeps global warming from getting out of control.
Oh.
And
Yeah,
but that
that's
also can kill things because corals and things like that don't like the acid. That's what causes like coral reefs to bleach and stuff like that. Less fish can live in acidic oceans.
I got that.
You did too?
No, that was what you said.
Just a little bit in here.
So is that pure CO2, Mr. Gesher? What? Yeah, I believe so.
Still alive.
There's still water. The best is still when you take hot water to start and just dump it in.
Yeah, I know.
I'm kind of
We
scared.
should you want to go some more hot water? Take it from the tap. It's hot enough for that.
Yeah, I know.
It's awesome. Here, take it out. It's just a ton of this.
Oh, you're trying to freeze it?
Can we do this again? Cool.
See that? That breathe on the table.
It's taking your breath and making it ice. That's so cool.
What are you doing?
Yeah, I don't know.
Yeah, do that.
With hot water?
What?
Hot water?
Yeah.
It's gonna like snap my way.
I know. Here we go.
Why does it make that noise?
Because this is so hot that it's causing this to they're causing it to vibrate against us because this is dissolving.
I
so
feel
fast.
like Dr.
Pressure
Frankenstein.
is forcing it all away from the ice, but I'm forcing it back. And it happens so fast that it's a
Makes it vibrate.
yeah.
Stuff.
Wow.
Whoa.
Why are you on here?
This is
Everyone's
warm,
just
right?
staring at
If you
it.
go like this, it'll stay in here.
Yeah, it stays in your hand. Oh.
Here, everything.
Yeah.
Are you gonna give this as a birthday present? Hey, yo. Hey, you have physics. What? Do it next year.
Yeah, sure.
That looks really cool. No! Oh, I mean, hey, yo! You just got water on myself. It's okay.
Oh, you just killed her!
What is it? Seriously? Let me next time then.
Wait.
She in her class.
Wired in here? Yeah.
Oh, she was
Yeah.
smart.
Stop taking all of it.
I did it!